Here we go. All right, so remember, we have done this 5-number summary. If I remember last time, I think I went through it. I reminded you of what it was last time. So I figured it'd be good to do some more examples of it. Okay. All right, so let's suppose we had this data, okay? And remember, here, notice there are 16 data values, okay? And what we want to do is, we want to get the 5-number summary. Okay. All right. So you really want to sort the data first. I mean, you can do that by going either to Excel or Google Sheets. I know Google Sheets, I wrote down how to do it because I figured Google Sheets is free, although I think Excel comes with most computers. But anyway, I figured it wouldn't hurt to do it through Google Sheets. You basically type the data in one column, highlight it, and then I tell you the rest. You click data in the menu bar, and then you tell it to sort, in whatever column you type the data in from A through Z. It will sort it for you. You do have to sort the data. That's just part of the process. Okay. Now, for the 5-number summary, 2 numbers are easy to get, the minimum and maximum. Excuse me, the minimum here is 1. The maximum is 10. Now, just by looking at the data, we can easily see that. Okay. Now, n is 16, okay? Now, to get the first quartile Q1, you have to calculate this L. This, I think they call it a locator. It's 0.25 times n, okay? Where n is how many data values there are. So in this case, 0.25 times 16. Which it turns out to be 4, that you can do that through a calculator if you want. Now, since this is a whole number, okay, what you do is you have to get the average of that number and one more than it, and that number plus 1, in other words. So in this case, for 4, we have to get the mean, which is the average of 4 and 5. Excuse me, of the 4th values and the 5th data values. I think I might have misspoken. I'm sorry about that. So for a whole number, what you do is you have to get some kind of mean. Here we get the mean of the 4th and 5th data values. That's what you want to get. Now here it turns out that they're both equal to 2. So the mean, of course, is going to be 2. So Q1 is just 2. I think I misspoke. I said you have to get the mean of 4 and 5, but that's not necessarily so. It's the mean of the 4th and 5th data value. So since I misspoke, I apologize for that. For the median, it's the same idea. In this case, you do 0.5 times 16, 0.5 times how many data values there are, which in this case is 8. 0.5 times something is half of it. Again, and this is a whole number. So we have to get the 8th and 9th data values and find the mean of them, meaning we take their average. So let's do that. So counting from the bottom, for the 8th data value, you have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's 3 and 5. I know it's listed here, but I just wanted to show you how you get the 8th and 9th data values. It's 8. And it's 3 and 5, excuse me. So you add them up, divide by 2, you get 8 over 2, which is 4. Now, Q3, what do we get? L is 0.75 times 16, okay? Which if you do that, that turns out to be 12, which is another whole number. If it was a decimal, remember, you have to round up to the next whole number. And then you get the data value in that position. So if this was 12.2, then you would get the data value in the 13th position, if it was a decimal. But since it's a whole number, 12, we have to get the mean of the 12th and 13th data values. So I mean, you could count from the bottom, which is starting at 1. Here we have 16, so 16, 15, 14, 13, and they're both equal to 12, so the mean of 9 with itself is just 9, of course. So this is the 5-number summary. 5-number summary. And remember, the idea is that 25% of the data, approximately, is between any two data values here. About 25% of the data. And also, you could draw a box plot. I mean, you could draw it by hand, but we can do it through Desmos. Okay, I've done that in the previous slide, so I'm not going to do it here. Okay, any questions on this? So here's another example. If here, this one's a little bit different because we do have data. It's given, though, through a frequency table. You know, you have the data values and the frequency with each one. So if you were to list the data values, if you were to list them one by one, 13 would be listed 5 times, 8 would be listed 6 times. 11 would be listed 10 times, and so on and so forth. And you could still get the mean, the mode, and the median, and the standard deviation here as well. I mean, the mode is easy. You just look for the number that has the highest frequency, although the mode may not exist. If they all have the same frequency, which can happen, then the mode would not exist. So here, 1 has the highest frequency, so the mode is 1. For the mean, remember what you do. You want to multiply each data value by its corresponding frequency, as you can see. Okay? Like so. And then what you do is you add up the results. And what you do is you add up the results. Okay? Good. Okay, and then of course you have to divide by the sum of the frequencies. So again, you multiply each data value with its corresponding frequency. And then, right, you add those products up, and then you have to divide by the sum of the frequencies. It turns out this is what you get, which turns out to be 7. So the mean here is 7. Okay, that's good. But how would we get the median? I mean, you could theoretically list all the data out, but I mean, personally, I wouldn't want to do that. What's nice is we don't have to. If you remember, well, you first always want to sort the data, right? You know, data values, that is. You have to keep each data value with its corresponding frequency, though. You have to keep each data value with its corresponding frequency. Okay, that's what you have to do. So each data value with its frequency, okay? You sort it though. You know, from smallest to highest. Then, okay, then to get the median, right? Well, there are 53 data values, right? Which is an odd number, okay? And for an n, if you want to divide by 2 and you get, in this case, 20, like decimal, so you round up. You know, if there's an odd number of data values, and in this case there are, you divide by 2, which will give you a decimal, and then you round up. So in this case, we get 27. We need the data value in the 27th position, or the 27th data value. If there was an even number, like say there was 52, then, just like with the quartiles, you would take the number, one more than it, and you get the data value. If there was, say, 52, you would get the data values in the 52nd and the 53rd data values and take their mean. You know, just like we did for quartiles. But we need the 27th data value. Okay, well, let's sort of list the data. We know the first 11 are equal to 1, right? Now, the next 5 data values equal 3. So that's, the next 5 after 11. So that's 12, 13, 14, 15, 16. All of them equal 3. The next 3 data values equal 5. Right? The next 3 after 16. So what is that? 17, 18, 19. Okay. And then the next, after that 5, the next 5 data values equal 7. That's 20 through 24, right? After 19, you could just count them if you had to. And then the next 6 all equal 8, right? So for 7, you had the next 5, which is 20, 21, 22, 3, 24, right? And those equal 7. And then the next 8, which is 25 through 30, not the next 8, what am I saying? The next 6, they all equal 8. But either way, you get the 27 data value is equal to 8. So 8 is the median. Are there any questions about that? I hope that made sense. I think it did.